This is the function we're going to graph. We will graph the line y equals negative 3x plus 5, where x is less than 2, and y equals 5, where x is greater than or equal to 3. Let's look at the pieces we're going to graph. We're going to use part of the line y equals negative 3x plus 5, but only where x is less than 2. We always want to know what happens at our boundary, so we'll substitute in x equals 2. When we do that, we get y equals negative 1, so we know our boundary of this piece is 2, negative 1. Because we don't get to include our boundary, we're going to put an open circle there. Pick another x that's in your domain. 0 is less than 2. You could have picked a different number. If you plug in 0, your y is 5, so I know that 0, 5 is on this piece. My other piece is part of the line y equals 5. I only use this where x is greater than or equal to 3. I always want to know what's happening at my boundary, so if x is 3, y is 5. I can pick any other x. 6 is a good x, and x is 6, y is 5. Okay, now we're going to graph our piecewise function in WileyPlus. We don't want the line that goes on forever in both directions, because we only get to use pieces of each of our lines. So we're going to use the ray for the leftmost piece. We're going to put the endpoint at 2, negative 1, and put the other point where we've already know we need a point at 0, 5. Notice that when we hover over these dots, we don't have coordinates to see, so as long as it looks pretty good, WileyPlus is going to be satisfied. We do need to be careful because the domain for this piece of the function does not include x equals 2, so we do need that open circle. So we're going to put an open circle over the point 2, 1. Looks really big, but WileyPlus just wants to be sure you know what you've got. The other piece of the graph is going to be part of the horizontal line where y equals 5, so we're going to grab the ray because it does terminate at one end and put the endpoint at 3, 5. Remember, you can't grab away from the dot or else you move the whole thing. So in order to swing that ray around, we grab the dot and swing the dot around, so we get part of the horizontal line where y equals 5 and it ends at 3, 5. This time we get to include that endpoint and we don't need an open circle. In case it happens to you in your graph, if this closed dot had coincided with 2, negative 1, even though this part of it needed an open circle because the second part came in and covered over that spot, you would not have put an open circle there. Let's go back to what we're supposed to have, and we're done.